In this video we're going to solve two questions using the binomial theorem. And the first question's a fairly standard question where we're going to get our coefficients from Pascal's triangle and just use the patterns that exist to help solve this problem. So the coefficients from Pascal's triangle are 1, 5, 10, 10, 5, 1. Now notice that the line that you use from Pascal's triangle is the one where the second number in the triangle contains a 5. Every line starts with 1, and the second number is equivalent to the exponent that we're raising the binomial to. Okay, then in our binomial, the first part of the binomial will start as x to the power of 5, I didn't really need those brackets, x to the 4, x to the 3, x squared, x, and technically if we wanted to put it in, x to the 0, but that's 1, so we don't need to bother. Now the second thing is to go through with our minus 4, our second term. So the first one would be minus 4 to the power of 0, but that's 1, so we won't bother. And then it's minus 4 squared, minus 4 cubed, minus 4 to the power of 4, and minus 4 to the power of 5. We need to put in plus signs. And now just tidy up. One thing you should notice is that the exponents of the two parts should add up to 5. So here, for instance, 3 and 2 add up to 5. The exponent of the negative 4 here is 1, so 1 and 4 makes 5. So this is x to the 5. Now, 5 times negative 4 is negative 20, so it's negative 20, x to the power of 4. Now this time it's negative 4 squared, which is 16 times 10 is 160, and it's positive, x cubed. Now the next one should be negative. There is a pattern. Negative 4 cubed is going to be negative 64 times 10 is negative 640, x squared. The next one will be positive, and we've got 4 to the power of 4, or I should say negative 4 to the power of 4, which is 256, times by 5 is 1280. And then the last one will be negative, because negative 4 to the power of 5 is 1024. Now, the second question's about the other extreme that you can get. Finding a particular term in an expansion is fairly difficult. This one's not the most difficult, because we've only got a single x term, even though it is x over 2. But we know that in any term can be written as this. So to get our Pascal's triangle coefficient, this combination, a combination can be used for that. And it's the first term to the power of n minus r, second term to the power of r. Just remember those two exponents have to add to n. So hence the term that we're after here is always one more than the value of r in these. So we're after a power of x to the 4, which comes from the first term. So we'll be after the third term, because it will start off as an x to the 6 and then a 5 and then a 4. The other way of knowing it's the third term is that n minus r must be equal to 4, and as n is 6, 6 minus r equals 4, so r is equal to 2, and so the term we're after is one more than r, which is the third term. So T3 is equal to 6c2 times by x over 2 to the power of n minus r, which is 4, and times by negative 5 to the power of 2, which, now evaluating NC2 is a little bit tricky. That will be 6 factorial over n minus r factorial, which is 4 factorial, times by r factorial, which is 2 factorial. And I'll keep going with the rest, so that will be x to the 4 over 2 to the 4, which is 16, times by negative 5 squared, which is 25. Now, just a little thing about the NCR part here. 6 factorial can be written as 6 times 5 times 4 times 3 times 2 times 1, which is 4 factorial, over 4 factorial times 2 factorial. So let's put 4 factorial times 2 factorial. So the 4 factorials can cancel top and bottom, and we're left with 6 times 5, which is 30, over 2 factorial, which is 2 times 1, which is 2. So in other words, that comes out at 15. So this is equal to 15 times 25 on 16, x to the 4, which is 375 on 16, x to the 4. And I guess we could reduce that down, but I think that's a convenient stopping point.